Hello viewers on YouTube. In this video tutorial, we're going to conclude our discussion on how to express recurring decimal in fraction. In the previous video, we discussed on how to express recurring decimal, where we have just a single digit that tends to be recurring. How we can actually express such kind of problem or situation, how we can express it in fraction. Now, in this video, we'll be considering how to express a recurring decimal that has up to 2 digits that tends to be recurring. How we can express it in fraction. So, let's begin. The process actually remains on the same. The only thing that is different is just 1, and it's as follows. So, if for instance we have 0.73 bar, and we are required to express this in fraction. Well, remember that we said that 0.73 bar, in other way, we can express it as 0.737373 repeating. So the 2 digits 7 and 3 will continue to be repeating themselves continuously, and that's why it may make sense. So basically, the first step we have to put into account is to let the recurring decimal to be equal to a new variable. So usually we use x. So if x is equal to our recurring decimal 0.737373 repeating. Now, in the previous video we said that at this point the next thing is to actually multiply both sides of the equation by 10. But remember, we said that that is all because we only have 1 digit to 10 that tends to be recurring. But now that we have 2 digits to be recurring, we won't multiply by 10, but instead multiply by 100. So we are multiplying both sides by 100 because of the fact that we have up to 2 digits that tends to be recurring. So this clearly means that what you'll be using to multiply both sides of the equation would actually depend on the amount of digits that is recurring in that recurring decimal. If there's 1, you're expected to multiply by 10. If there's 2, you multiply by 100. If there's 3, you multiply by thousands, and it continues like that. And that is the only thing that is different in the process. Okay, that's the only thing that distinguishes the process of solving those kind of problems. So multiplying both sides by 100, we have 100 multiplied by x to be equal to 100 multiplied by 0.737373 repeating. Perfect. Now let this be our equation 1, and let this be our equation 2. So basically now, let's simplify equation 2 a little bit. 100 times x is 100x, and that's now equal to 100 times this entire decimal. We'll actually shift the decimal point 2 times to the right, and thus we will have 73.7373 repeating. Am I communicating? So now basically we need to subtract the 2 equations from one another. So now to make this simple, let's try to bring equation 1 all the way downward, because we are actually subtracting equation 1 from equation 2. So this is still our equation 2 for the simplified form. So bringing equation 1 all the way down, we have it as x to be equal to 0. Now, arranging this, you have to make sure that the decimal point is in line. Remember by process. So we have 7373 repeating. Now, if you are wondering why I didn't write the third 73, because it's not necessary. Yeah, it's not necessary. Okay, it's already among the infinite dots I represented over there. Now, basically, we need to subtract the equations. Okay, so equation 2 minus equation 1. So 100x minus x, it gives us 99x, and this will be equal to, now subtracting this, we have to be careful. We have to subtract whole number from whole number and decimal fraction from decimal fraction. So 73 minus 0 is still 73. So we have 73 points. Now these will entirely cancels out, and left over will be 0. So thus, if we divide through by 99, we would have our value of x to be equal to 73 divided by 99. And this should be our final answer to the corresponding fraction to the recurring decimal 0.737373 repeating. However, before you actually conclude, you can probably investigate if you can actually reduce your fractions. But clearly, nothing, since 73 is a prime number, nothing can actually split it into. I will actually reduce it and 99 at the same time. So that's our final answer. On to example number 2. So, by the way, if you are yet to subscribe to my channel, please feel free to subscribe. If you are enjoying the video, feel free to leave a like so YouTube can recommend it to many others out there. So we have 4.73 bar. So basically, we need to express this as a fraction. So we know that we can actually rewrite this as 4.737373 repeated. So we can end it with ... showing that it has no end. So right now, we can now begin our solutions. So the first step is to let x to be equal to the recurring decimal 4.737373 repeating. Now, if we denote that as equation 1, the next step is to multiply both sides by 100. Because of the fact that we have 2 digits of numbers to recall. So 100 multiplied by x will now be equal to 100 multiplied by 4.737373 repeating. Excellent. Now, if we simplify this, 100 times x is simply 100x, and that will be equal 100 multiplied by 4.7373 repeating. We'd actually shift the decimal point 2 times, and thus we will now have 473.7373 repeating. So we can denote that as our equation 2. So basically, we need to bring the equation 1 all the way down to equation 2. And we have it as x to be equal to, now in doing that, we have to make sure that the decimal point is in line. So therefore, since this 4 is a unit value, it has to be in line with the unit value of this 473. So it has to be somewhere around there. Thus we have 4.7373 repeating. So that's our equation 1. So at this point, we can now subtract. 100x minus x is simply 99x. And that will now be equal to, this can be seen as 0, 0. Okay, just like 004. Because the 10 value and the 100 value are nothing but 0. So 4 minus 0, we can start from the back, right? This will cancel out. Excellent. Now 3 minus 4 is actually impossible. So thus we can pull 1 from this 7 and have it to be 13. 13 minus 4 would gives us 9. So we have 9. This is 0, that is 1 point. 9. Now this is left with 6. Let me write that properly. So 6 minus 0 is 6. And then 4 minus 0, simply 4. So those, we now have 99x to be equal to 469. So basically at this point, we can divide through by 99 in order to isolate the value of x. And therefore, we have our x to be equal to 469 divided by 99. So the question is, do we have any number that can reduce 469 and 99 at the same time? What do you think? Well, I can't think of any number at the moment. So you can use that as an exercise. Let me know in the comment section below. What number do you think can reduce it? If there's not, then this should be our final answer. And that gives us the solution to the corresponding fraction to the recurring decimal 4.7373 repeating. So by now, I want to believe you should have understand how to easily express a recurring decimal where up to 2 digits of recurring into a a fraction. So I hope you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now. So, as always, this exercise I have for you. I hope I can just have that copied down or written down on the side. So you are expressed or you are required to express the following common decimal in fraction. So the first one is 5.619, where we have a bar on the 1 and 9, which means that the 1 and 9 is repeating continuously. And the second one is 0.253 bar. So feel free to share your solution with me via the comment section below. Thank you once again. Bye for now.